Oh, hey gamers! As you already noticed, I'm playing a bit of ET. I could not stop playing after I managed to make it work on my DIY cartridge in the last video. It's such an addictive game. How can you resist?
Now I think it's time to finish this cartridge project by taking advantage of the free space in this EEPROM chip by filling it to the brim with games. I've been preparing a list of games that I would like to add and I can't wait to load them in. Ideally, it would be perfect to have a nice menu to pick the games from. Unfortunately, that's beyond my skill set. So, we're gonna use the next best thing.
These switches. Oh yeah, that's going to be the most important part that we're gonna add to this cartridge. I bet that would make this video least complex of the previous two. Also, with the switch, we're gonna need some 10k ohm resistors. I'm hoping there will be enough and Atari won't burn them. I would like to add these red LEDs just for fun, they are not that necessary. And with LEDs we need some 330 ohm resistors. As I mentioned in the previous video, I would like to add a switch to turn bank switching on and off. So I managed to salvage this beefy switch, so we're gonna use it. Okay, that's basically all the parts we need, and of course some soldering equipment as usual, and some wires and clippers too.
Let's solder in the big switch in the right corner of the PCB. The idea is to have the bank switching by default, so when the switch is in this low state we have the F8 bank switching working. On one end of the switch I'm soldering the output of the flip-flop and temporarily connecting the ground to the other. The switch result will be connected to the A12 of the EEPROM. Let's solder in an LED. Got to watch out for the right LED polarity. The longer leg means it's plus and the shorter is minus. Then let's connect a 330 ohm resistor to the ground of the LED to limit the current and prevent the LED from burning down. Now we solder the other end of the resistor to the common ground. Let's connect the output of the switch to the plus of the LED. Now we got the switch going, let's test it out. Here we have the hero demo running. And look and behold, it's actually visible how the bank switching is working. The LED lights up every time the upper 4 kilobyte bank is accessed. For some reason, it's only clearly visible on the phone's camera. Normally, if you look at it, the LED is constantly burning. Maybe dimmer, but the blinking is not that obvious. Now let's put an EEPROM with a 4 kilobyte game. Turn the bank switching off by pulling the switch up and voila! The 4 kilobyte game is working too. So I've already soldered the dip switch. Now let's finish soldering in the remaining 3 LEDs. Then we need to attach a current limiting resistor for every LED. Now we should solder in pull-down resistors for each dip switch. These are 10K ohm and should lock in the address state we are going to switch, because even if the switch is off, there still might be some current flowing and the logic circuit might think the address state is 1. So without these resistors, the address bits might wander back and forth from 1 to 0 and crash the console. Let's connect each resistor to the lower pin of the dip switch. Now let's connect together the ground of the LED resistors and the switch pull-down resistors. Now let's connect 5 volts to the upper dip switch pins and connect the upper pins together. Now we are attaching a wire to the first switch of the dip switch. The other end of this wire should be connected to A15 of the EEPROM. But first we need to remove the ground wires that we attached to that address pin during the first video. Let's connect together those two leads that were attached to A15. Now let's finally attach the switch to A15. Now let's connect the positive lead of the first LED to the lower pin of the first switch. So in order to test the single switch, let's make a ROM which would consist of many games. So as you see, I have a folder here full of games, and also I placed a list here that I created. Here we have 4 columns that represent address bits from A15 to A12 and also the 4 switches. The 4th switch is not that important since it's only for 4 kilobyte games. Our goal now is to test the first switch when it's on and all other switches are off. The game that should load should be Star Trek. Okay, let's create a ROM. We have a bunch of games, now we need to join them into one big binary blob. For that we are going to create a batch file. New text document, let's call it make blob, rename the extension to bat, of course. Let's edit it. We're going to use a command named copy with a parameter /b, which stands for binary. We're going to copy all these game ROMs into one binary file, and we're going to use this list as a reference. The first one is Hero. Click F2, Ctrl A, Ctrl C. Now let's write 2 quotes here and click Ctrl V. Now write a plus sign. The second game is Zaxxon. Same as previously. F2, Ctrl A, Ctrl C. Add some quotes, Ctrl V, and we're going to repeat that until we reach the end of the list. Okay, next we have 2 4 kilobyte games. For this type of cartridge, it's best to combine 4 kilobyte games in groups of even numbers like 2, 4, 8, and so on. If I would put, let's say, 3 or 5 4 kilobyte games in a row, I would mess up the addressing and my switches would become useless. And the last one is pressure cooker. So now let's write the name for our Mega ROM. Let's call it Mega ROM. Then let's save the batch file. Let's run it and got a 64 kilobyte binary file. We can check it with Vim. Vim has a feature that lets you see the hex numbers, so we can see the data. We're gonna compare this when we load the file on the XG Pro. So let's run XG Pro. I already inserted the chip. Okay, let's read the EEPROM. Okay, looks like it's all FF, so it should be empty. So now load our Mega RAM. Yep, all the default settings are in. We're not gonna change anything. So let's scroll down to the bottom. Let's compare what's on the... So yeah, we have loaded a entire file into the buffer. Now let's program the chip. So let's hit program and program. Now it's gonna take a while, I think. And we're almost... Looks like we're almost done. Okay, I guess we're done. Let's put the chip into the socket and let's test it out.
Yeah, let's put the cartridge in the console. Get in. It's in. Turn it on. Yep. We got Star Trek. Let's try to play it. And it works. Alright, now let's test the switch. Okay, shut up. Now we're gonna pull the switch down. So A15 will be 0. Now we should load Hero. And what do you know? It works. Okay, let's solder remaining wires.
We need to remove unused ground wires and unsolder them from A14 and A13 EEPROM pins. Let's solder new wires to A14 and A13 and connect to second and third switches. Attach positive LED leads to the switches. Remove temporary ground connection to one of the big switches pins and replace it with a wire that leads to the fourth dip switch's lower pin. Apparently I made a mistake here and incorrectly soldered LEDs. Let's fix it.
Looks like we're done. So we have all the wires connected to the switches. Let's test the games on the EEPROM. Okay, So currently all switches are off, well, except the bank switch. Now you're seeing it runs Hero. So since it's the first game, let's flip the switch and see what game do we have next. I haven't anticipated it would be so hard to flip those switches, so I have my toothpick. I think it's easier to switch them up than to switch them down, so switching off I will use the toothpick. So now the
Second switch is up. Let's see what game we have here. Oh, it's some kind of buzzing, but the game works. It's Zaxxon, so yeah, it's working. So okay, as you see, this LED shows that this bit is on, so address bit 13 is 1. So okay, let's turn it off and try another game. So okay, so it's 1. 2 in binary would be 10. So we need to flip the switch on. Let's turn the console on. Okay, so I have Enduro, so that means I have two games in a row that are 4 kilobytes. Let's see if we can get the first game. And we have Keystone Keepers. So okay, so third 8 kilobyte block is working, so we have 2 games there. So turn it off. Let's try flip on the. So now we're gonna switch to. You see, it's 11 on binary, and let's enable bank switching, and let's turn it on. And it doesn't work. So there should be, I think, Montezuma's Revenge, but it doesn't work. Right. Let's try next combination. So we need to flip them down and flip this one up. Oh, it's so hard. Okay. And let's see what's. Okay, so we have stab track as I shown before. Now we need to increase 1 bit. Let's see what's the next game. Okay, so let's see what we have here. Okay, so that's another 4 kilobyte game. Oh, interesting. So I think we need to, but now I think there will be different game. So yeah, we have Flash Gordon. When the ship is destroyed, the console crashes. It's kind of interesting. Let's try to play it. I want to crash the ship. Oh, it's all fine. So it's no longer crashing. That means during the gameplay, when the ship crashes, like bank switching is enabled for some reason. Okay. So those 2 games working. Now we need to lower this bit and pull this up. So we have 110. Let's see what. Okay, so I have here robot tank, but it doesn't work. Oh, maybe that's because bank switching is off. Nope, still doesn't work. Interesting. What will happen if I lower this switch down? Ooh. So robot tank also doesn't work. Okay, let's increase the bits, and that will be, I think, our last game on the cartridge. No, it's easier. Finger. Okay. So we have now it's 111. So that's the last game, and that's pressure cooker. That's a cool game. So yeah, it works. So that's it. So we have, I think, 8 games out of 10 working. Little did I know that apparently F8 bank switching is not enough for all 8 kilobyte games. The Montezuma's Revenge didn't work because it used a different kind of bank switching, so-called E0, a technique used mainly in Parker Brothers games. Robo-Tank was totally a different case. It was using FE bank switching, which is used only in 2 games in total. So I tried replacing faulty games with something else. Instead of Montezuma's, I added Cosmic Commuter and Haunted House. And in place of Robo-Tank, I put Frostbite and Crackpots. It's about Dan vs Spiders. After testing new ROM, I got another disappointment. The Haunted House did not work as it should. It seems the main character, the eyes, is strangely mirrored in the left side of the screen, when it should be on the right. I guess not everything's that simple, even for the 4KB games. So 3rd time's the charm. Had to replace Haunted House with Chopper Command.
So in total, I managed to place 12 games of varying sizes into this 64KB chip. As you saw, the cartridge isn't perfect, and there's still a lot of improvements that could be done, like implementing all the missing mappers, but I think that's enough soldering for now. Perhaps I will return to this project in the future. Now I want to know more about 2600 and how it works, and I'm gonna learn that by making my own game from scratch. Also, I think that would be a challenging video to make, because game development in reality is way more boring to watch than my soldering, but I like challenges. So thanks for watching, hit the like button if you liked my cartridge project, and see you next time. Bye!